Hello everyone. Today we will discuss about processing of vanilla beans and production of vanilla flavor. In this, the different aspects of vanilla processing, vanilla pods processing, packaging and storage of processed and cured vanilla beans, extraction of vanilla flavor from the cured beans, production of vanilla flavor from other sources, and finally application of vanilla flavor in different food products will be discussed in today's lecture. So, let us see what is vanilla. Its botanical name is Vanilla planifolia. The genus Vanilla belongs to the family Orchidaceae. Vanilla is a climbing orchid indigenous to Mexico. You can see here in the figure, it is a climbing orchid. In commerce, vanilla is cultivated in tropical regions and is propagated by cuttings. Vanilla beans are harvested green, flavorless, and they are next subjected to a curing process for about 3 to 6 months, depending upon the various curing protocols in different production regions. You see here in the figure, this is the vanilla beans as they are harvested from the orchid. Vanilla pod contains many aroma compounds including vanillins, okay, but they are present in the green beans in the form of glycosides, mainly precursor of these flavors. Vanillin is the most abundant aroma compound in the cured beans. It is approximately at about 2% level. Other important constituents are para-hydroxybenzaldehyde, para-hydroxymethyl ether, and acetic acid, and some other minor components are also present. Okay. As far as the processing of vanilla beans is concerned, in the earlier classes, in the coffee, in the cocoa, you saw that yes, they are so naturally produced or cultivated beans do not have the characteristic flavor. Similarly, here also in the case of vanilla, that is the green vanilla beans contains very small amounts of vanillin and it is odorless and flavorless. So, in the commercial practice, mature green beans are subjected to curing process, which allows the characteristic flavor, aroma and color to develop, and also excess of the moisture is removed, which prevents spoilage of the bean during storage. So, the curing of the beans has particularly 4 stages you can say, that is scalding or killing, sunning or sweeting, then drying and finally conditioning. Okay. You see that completely brown colored beans are obtained after drying and conditioning. Earlier they were green color. Okay. So, the curing is a process involving alternative sweeting and drying of pods until they lose most of their moisture content, that is as much as about approximately 80% of the total moisture content is removed in the curing and drying. The process of curing is an important stage as the bean undergo the enzymatic reaction which are responsible for the development of characteristic aroma and flavor. You can see here in the figure that different stages of curing as they follow in the industry or in the farm level. So, curing brings about physical, biochemical and chemical changes which are necessary for imparting the desired attributes in the beans. So, if let us see what happens in the actual curing step, individual curing steps, that is in the killing, the first step, it is here vegetative development of the fresh bean is stopped and enzymatic reaction responsible for the production of aroma and flavor are initiated. So, this process is called killing because it disrupts the respiratory functions by destructing cell membranes and cell walls of the bean tissues. thus bringing about their physiological death, and that is why it is told as a killing process. The method used for disruption of the cell structure are hot water scalding, sun and oven wilting, saccharification, treatment with ethylene gas and freezing. The most common methods are sun, oven and hot water killing. The next step is the sweeting. Here moisture is initially allowed to escape rapidly to attain a level which reduces the risk of microbial spoilage during the subsequent operation, but sufficient for further enzymatic activity. That is, the moisture after this sweeting process, it should be sufficient for the enzymatic activity. During this stage, vanilla bean develops their distinctive color, fragrance and flavoring qualities. Improper bean handling at this stage results in significantly inferior beans. Sweet boxes are the enclosed chambers, and in rare cases ovens are even used for the sweeting procedures. You can see here different boxes and chambers and ovens, etc. Okay. The procedures, it may take about 7 to 10 days to complete the sweeting process, and finally at the end of the sweeting period, the cured beans, which are now brown in color, okay, and aromatic, they contain about 60 to 70% moisture. So, the beans need further drying to reduce their moisture content in order to protect them from microbial spoilage and allow for the further beneficial chemical changes to take place. So, the reduced moisture content of the beans after drying also minimizes undesirable enzymatic activity and biochemical alterations. The bean after the drying has around 25 to 30% moisture content. Okay. Then finally, the dried beans are conditioned. The beans are held in tight boxes, as you see here in the figure, for the conditioning purposes, and this steps from 1 month to lasts from 1 month to around several months, depending upon the conditions during this process, environmental and other conditions. During this process, several chemical and biological events such as esterification, etherification, oxidative degradation and so on occur, which produce diverse aromatic compounds and improve the overall flavor quality of the cured bean. So, conditioning also is very important step. So, here are some curing method in the Mexican process of the curing. Harvested and sorted beans are placed in dark woolen blanket and are exposed to sun for about 4 to 5 hours. Wrapping of hot beans and placing in sweet boxes, and the sweeting is continued for about 24 hours, which is followed by drying in sun for 4 to 5 hours, rolling and again sweeting. Then sunning and sweeting is repeated for about 6 to 8 times, and finally it is given shorter exposure to sun for about 2 weeks. Then slow ambient drying, in the sun drying or even mechanical drying may be there, but normally they do the sun drying, and which is followed by about a month or so, and this is followed by conditioning for about 3 months, and this conditioned bean are then graded, bundled and packaged, and total curing time in this process, it takes about 5 months or so in the Mexican process. Then there is a bourbon process, in which also there is the harvested and sorted beans are scalded at 65 degrees Celsius for 2 to 3 minutes, which is followed by quick drying and wrapping of hot beans, sweeting for 24 hours, then drying in sun for 2 to 3 hours, hot rolling and sweeting repeated, and sunning and sweeting repeated for about 6 to 8 times. Then it is followed by slow ambient drying for about 2 to 3 months and conditioning for 3 months, which is finally conditioned beans are graded, bundled and packaged. So, total time in this process may take about 6 months. Okay. Then in the CFTRI process, in fact, total curing time has been reduced significantly. It takes around 1 month to 32 days, etc. So, the harvested beans are graded and sorted. They are scalded at 65 degrees Celsius for 2 to 3 minutes, and then sweeting is allowed for 24 hours, followed by drying at 50 degree plus minus 5 degrees Celsius for 4 to 5 hours daily. Then hot rolling and sweeting for 24 hours, drying, hot rolling and sweeting is continued for 6 to 8 days, and which is finally followed by slow ambient drying at for about 6 to 8 days, conditioning 10 to 12 days, and finally grading, bundling and packaging. Regarding packaging and storage aspects of the processed beans, packaging of the conditioned bean aims at reducing the water exchange with the environment. The bean mass relative to the surface area is exposed to the environment should be large to minimize water exchange, and packaging environment have no effect on the stored beans. So, in the traditional method of packaging in Madagascar and Mexico, a bundle consisting around 50 parts is stored in tin or cardboard boxes, which prevent moisture exchange, but it does not prevent gas diffusion. So, beans are also kept in loose state in a cardboard box, which may be lined with wax paper, or it is used for low grade beans destined for extraction purpose. But the improved process is the vacuum packaging, better process. Here beans are packaged under vacuum in sealed plastic films. Size of the package may vary from 100 gram to 10 kg, and it prevents both the moisture and gas exchange within the ambient atmosphere. And now, after it has been processed and packaged and cured, so cured vanilla bean, let us now see that how the vanilla flavor is synthesized, produced inside the cured beans. So, as I told that vanillin and its precursor, they are absent in the vanilla plant and vanilla just harvested vanilla beans, but they are only found in the mature vanilla parts. There are two process, ripening process. The vanillin level gradually increases in the form of its glycoside, reaching a maximum at the harvest, that is 8 to 9 months post pollination, and then the most of the finally majority of the flavor compounds are developed in the curing process. The vanillin glycoside is hydrolyzed by glucosidase activity during the curing process by the end, and most of the glycosides has been converted into vanillin. So, this is one of the possible route has been suggested to vanillin biosynthesis in the vanilla beans. That is, there is a in the ferulate pathway where aromatic ring of C6 to C3 compounds, that is transcinamic acid and paracoumaric acid, undergo hydroxylation and methylation to ferulic acid, which then undergo chain shortening to vanillin. In the benzoate pathway, chain shortening of a phenyl propanoid first metabolic event, which is followed by hydroxylation and methylation of the aromatics. Then in the cyclamic acid pathway, the phenylamine undergoes deamination to a C6 and C3 phenyl propanoid, that is paracoumaric acid, and then this paracoumaric acid is converted to a para-hydroxybenzaldehyde, which is then reduced to para-hydroxybenzoyl alcohol. Then 3,4-dihydroxyphenyl alcohol can be either methylated to 4-hydroxy 3-methyl-benzoyl alcohol, or it can get oxidized into 3,4-dihydroxybenzaldehyde. 3,4-dihydroxybenzaldehyde can be methylated to form vanillin, or 4-hydroxy 3-methyl-benzyl alcohol can be oxidized to vanillin. So, either of the routes. So, these are the proposed compounds, etc. They are structural figure. So, that is how that this vanilla or precursors, etc., they are converted into vanillin flavor compounds. So, the components of vanilla flavor, you can see there are about more than 250 compounds influence the vanilla flavor, okay, and the quality of the cured vanilla parts. vanillin is around, which is 1 to 2% of the cured part, is the major compound. Okay. Other compounds influencing flavor include volatiles such as monoterpenes, equiterpenes, ethers, arenes, phenolics and lactose. Also there are various precursors, that is putative precursors of vanillin contributing to the aroma and flavor of vanillin are like para-hydroxybenzaldehyde, which is normally sweet tasting, vanillic acid, they give the organoleptic properties of chocolate, creamy, grape, nutty, wine like, or para-hydroxybenzoic acid, which are vanillin alcohol, they are mild sweet plus thick or vanilla like odor. Here now this natural vanillin may be extracted from various different agri-hearty produces, and this slide shows that is one is the vanilla pod, that is the cured and dried vanilla pod, conditioned vanilla pod is used and it is subjected to extraction and we get natural vanillin. So, apart from this, even rice bran has ferulic acid and it is a ferulic acid by the process of bioconversion by fermentation is converted into vanillin. Corn, the glucose, and this glucose also by de novo biosynthesis by fermentation process, and in many countries, European countries or US countries, they are using this raw materials, agricultural, horticulture raw material to produce natural vanillin. That so this is also that this turmeric contains curcumin. This curcumin is bioconverted by fermentation into eugenol, that is into natural vanillin. And other very important source which is used by the industry commercially to produce vanillin other than the vanilla bean is the clove, that is clove eugenol. It contains essential oil eugenol, and this eugenol either by soft chemistry and fermentation, okay, or bioconversion by fermentation, it is converted into natural vanillin. So, these are the natural sources for getting the vanillin. Okay. So, as far as the extraction of vanilla from vanilla beans is concerned, you know that it is available commercially in the form of vanilla essence. Okay. Natural vanilla extract is sold as a dilute ethanolic extract containing about 1 gram per liter vanillin. So, the commercial extraction techniques include percolation method or oleoresin method. In the percolation method, that is a circulating mixture of ethanol and water containing 35 to 50% alcohol for 48 to 72 hours, and this is in this the powdered vanilla beans are extracted, and this results in a 4-fold strength vanilla extract. Okay. In the oleoresin method, it consists of pulverizing whole pods and then circulating ethanol over the pod under vacuum at around 45 degrees Celsius. So, the excess ethanol is removed by evaporation, and this process takes about 8 to 9 days. It results in 10-fold strength of the vanilla extract. Okay. Other methods for extraction may be succinate extraction, supercritical carbon dioxide extraction, microwave assisted extraction, ultrasound assisted extraction or enzymatic extraction, solid phase extraction. So, all these various methods which we have their principle and method of operation etc., we have already discussed in earlier classes. So, they can also be used for extraction, but it is better to go for the microwave assisted or US assisted extraction process or supercritical CO2 extraction process, so that at least the flavoring compounds there that is the purity can be retained and their flavoring potential, maximum flavoring potential is obtained in the extract. Then for the production of vanillin from eugenol, that is the clove essential oil, that is eugenol, it is reacted with KOH, then it converts to isoeugenol and which is finally oxidized into vanillin. This is very simple way I have told, but this is a very complex group of reactions are there. Okay. That is a series of complex reactions are there by which eugenol is converted into vanillin. So, upon completion of this reaction, an equimolar amount of nitrobenzene is introduced slowly into the autoclave, and when the resulting oxidation to sodium vanillate is completed, the batch is cooled and the permanent gases are blown off. By solidification of the batch, vanillin is precipitated from solution and recovered by filtration. The vanillin yield in industry is approximately 80% of the theoretical value of eugenol. Then production of synthetic vanilla flavor from paper industry waste, and in the also that in the market that synthetic vanilla is available also in this for use in various products. So, in fact, it is a vanillin or synthetic vanilla is prepared artificially from kraft lignin, which is a byproduct of paper industry. The black liquor produced from kraft pulping process consists of organic and inorganic parts, and thus kraft lignin is the largest constituent in the organic part, that is about 30% of the total dry solids in black liquor. So, this process consists of two sections. One is the reaction section, where that feed is prepared, all right, and it is fed into the reactor output. Okay. And then separation section, that is vanillin product from the reaction section is purified using three different methods. So, in the reaction section, as I told you, what is done here, feed, that is the lignin, air, sodium hydroxide and water. They are fed into the reaction vessel. Then oxidation conditions are given for oxidation to take place, oxidation of the feed, and then neutralization of the oxidized feed is also carried out in the reaction section. And finally, the solution moves to the separation section, okay, after the reaction is over. In the separation section, there is a distillation of the neutralized solution is carried out. It follows evaporation, crystallization and washing operations, and at last the vanillin is recovered after drying. Three different types of separation steps are used, that is case 1 where liquid extraction is followed by distillation, case 2 two-stage liquid extraction, and finally even vacuum distillation. So, these are the very complex chemical reactions, and where by which these compounds are transformed into vanillin, synthetic vanilla. Okay. Now, let us discuss the application of vanilla flavor in food products. Vanilla is the one very commonly used flavoring materials in both that is in the various products like dairy products, in beverages, in baked good, confectionery products, or it is also used as a flavor enhancer in the market. As I told you, both vanilla is available in the form of essence, or vanilla is available in the form of flavor as a vanilla essence, that is the natural vanillin extracted from the vanilla beans or from the other natural agricultural or horticultural produces, or the synthetic vanilla produced from the paper industry liquor waste also. Okay. So, in the dairy products, vanilla is used as a flavoring for ice cream and even some other product, yogurt, etc. The category of vanilla used determines the labeling of ice cream. Category 1, that is natural vanilla extract, two-fold vanilla is used, and thus ice cream product is labeled as vanilla ice cream. Under category 2, vanilla vanillin extract is used, and this is considered as natural and artificial, both N and A, where the natural component is the characterizing flavor, and ice cream products are labeled as vanilla flavored ice cream. And third category includes where natural and artificial vanilla flavors are artificial vanilla flavors, where the artificial component predominates. Okay. And ice cream product in this category is labeled as artificially flavored vanilla ice cream. So, vanilla ice cream, vanilla flavored ice cream, or artificial flavored vanilla ice cream, depending upon the nature or form, whether synthetic or flavored or combination of both is used. In the bakery products, that is pure vanilla extract is not used for baking because the aromatic components of extract begin to vaporize or volatilize at about 135 to 150 degrees Celsius, which is a temperature that is readily attained in cookie baking. So, cakes rarely exceed 100 degrees Celsius during baking process internally. So, an extract or blend of extract may be used, even synthetic or natural vanilla or vanilla extract can be used, because here the temperature is not very high. But in the product, in the bakery product where temperature is very high, maybe 135, 150 degrees Celsius or more, there this natural extract their use may be avoided, and there the vanilla, vanillin extract, etc., or artificial flavors are recommended in such baking operations. Natural and or artificial flavors can be used with various flavor notes such as buttery, nutty, brown sugar, and so on. In the beverages, that vanilla is an important flavor component in cola drinks, soft drinks, cream soda, root beer, and some fruit beverages also contain vanilla. Vanillin or vanilla flavors are used in many alcoholic beverages such as even whisky, cordials, and cocktails, and here they are used to round out and smooth the harsh edges of the alcohol which is there. So, such alcoholic beverages, they improve the flavor. Then the vanilla is used as vanillin is used as a flavor enhancer in various products like in chocolate or in the food or sweet flavors or in the sweeteners, etc. sweetness. So, in the chocolate, vanilla softens the round out harsh bitter notes in most of the chocolate applications such as ice cream, that is where the bitter chocolate is used in ice cream, cakes, etc. So, when these bitter chocolate together with the vanillin or vanilla flavor is added, then it improves or it reduces the bitterness of the material. So, in confection such as chocolate bars, powdered vanillin is used to do the job. The fruits or sweet flavors, the vanilla is used to enhance fruit flavors in many dairy and beverage application. It rounds out many fruit flavors and takes off some of the tart edges. As about the sweetness, that vanilla enhances the sweetness perception of foods and especially in the bakery product. So, the vanilla is one very, very popular and commonly used flavoring materials in various foods. Okay. So, I will say now that is the vanilla flavor, the major principal component which gives the flavor of vanilla is the vanillin, and this vanillin can be obtained naturally from the vanilla cured vanilla beans or from eugenol, from the clove essential oil, from the rice that is starch or corn starch, which can glucose, etc., or even from such other agricultural materials. Okay. And it can also be prepared directly, that is it is from the paper industry waste or some synthetic vanillin. So, although the consumers like obviously that natural, there is a trend that is the natural component, natural flavor, but if you look at the production cost and other things, this synthetic flavors, synthetic form is quite cheaper. The natural extractives are 200 times more expensive than its synthetic counterpart, because cultivating and producing the vanilla beans, then curing, and after curing the extraction of the material is quite costlier process. Novel technology has to be used, innovative technology for the extraction, so that and mostly supercritical fluid, carbon dioxide or such other innovative methods, when they are used, obviously it will involve the cost, it will have more cost. So, means that is a good harvesting and practices should be done, and beans should be properly cured, conditioned, and then extracted using novel technology, so that you can get a good quality, that is vanilla essence. Okay. And the temperature, humidity, and gas composition, etc., are some of the important issues which should be taken care of while packaging and storage of the cured bean as well as even the extracted essence, that is extracted flavors, etc. This should also be properly packaged and kept in the container suitably, so that its volatiles does not get evaporated. These are the references which has been used in this lecture. Finally, thank you very much for your patience here. Thank you.